Okay, so the last thing we're going to talk about here is the divisibility rules. So I asked you guys to look at these and see if you could come up with some connections between some numbers, and be interested to see what you come up with when you did that on that very first day's activity or first last video's activities. But what I want to do is talk about these divisibility rules. What divisibility rules are is they are, quote, shortcuts on ways we can tell if a big number will be divisible by a smaller number. So these numbers here, there's some things that we can identify about them that make them easier for us to know, hey, this number is going to be divisible by that number. Okay, so you may know some of these already, and I'm going to teach them kind of in the order by which I think they should be taught, obviously. And then we're going to make some connections kind of at the end. So the first one I think that's easy for students to understand is the 2. So what I mean here is I'm gonna go ahead and put an example up here, a problem. So let's say our number is 5,273. Okay. So the question is this number divisible by 2? Do that one actually. Is this number divisible by 2? 5,272. So the way we know that is we look at the ones digit, and if the ones digit is even, then this whole number is divisible by 2. If the one digit is odd, then this whole number is divisible by 2. So since 1 is an odd number, this would not be divisible by 2. So the rule for divisibility for 2's is if the number is even, then it's divisible by 2. Then yes. Okay? So if the number's even, if it's an even number, and we do that by looking at that, then it's divisible by 2. So that's probably the easiest one, right? So if it's an even number, it's divisible by 2. If it's an odd number, it's not. Okay, the next easiest one, I think, is 5. I think 5 is pretty easy, and you're going to argue with me probably that the one after 5 is easy. But 5, this number here, 5,271, that will be divisible by 5 if this digit ends in a 5 or a 0. So if this number right here, the ones digit, is a 5 or a 0, then the whole number would be divisible by 5. So this would be no, because that's not a 5. So this number is not divisible by 5. So if the ones digit, the ones digit is a 5 or 0, then yes. Okay, so that's the only 2. If it ends in a 5 or a 0, then it's divisible by 5. And the next easiest one, which you guys are probably going to do, this one's easier than the last one, I don't disagree, is 10. So this number is divisible by 10 if that digit is a 0. So if the ones digit is a 0, then yes, it's divisible by 10. All right, so if this number, this one will not be because it ends in a 1, but if this number ends in a 0, then it's divisible by 10. These are probably the 3 easiest ones, right? Because all you're really doing is looking at that last digit. If it's even, it's divisible by 2. If it's odd, if it ends in a 5, it's divisible by 5. If it ends in a 0, then it's divisible by 10. If it ends in a 0, it's divisible by 2 and 10, because 0 is even, so that means 2 works, and it ends in a 0, so that means 10 works. And in fact, it's also divisible by 5, because if it ends in a 0, then 5 works. So it could be multiple, obviously. Okay, those are the 3 easiest ones. So let me kind of put those bingo, bango, bongo. All right, now let's see. So another one that you may kind of know something a little bit about is 3. All right, so 3 is a little bit different. So for 3, I'm going to add or find the sum of the digits. Okay, so I take the sum of the digits, and if that number is divisible by 3, then yes, the whole number is. Okay, so I'll show you what that means. So that means that I go 5 plus 2 is 7, plus 7 is 14, plus 1 is 15. 15 is divisible by 3. That means this would be, yes, divisible by 3. Okay, so if I can add all these digits together, 1 plus 7 is 8, plus 2 is 10, plus 5 is 15. 15 is divisible by 3, therefore the whole number is divisible by 3. Okay, so that's a pretty cool one. Then I'm going to do the next one is very similar to that, and that's 9. It's the same rule, except if the total is divisible by 9. So the sum of the digits is divisible by 9, then yes. Okay, so we just added this one up and it was just 15. 15 is not divisible by 9, so that means this number is not divisible by 9. It is divisible by 3, but it's not divisible by 9. Okay? So, all right, so that's pretty cool. So that's this one here, and then this one here. And now the next one actually is 6. 6 is a cool one. So 6 says, if 2 and 3 work, then 6 works. Okay, so if 2 and 3, if a number is divisible by 2 and 3, then that means the number is also divisible by 6. So if it's even and this rule for 3 works, then it's also going to be true for 6. So when you check 2 and you check 3, if those are both yeses, then you know 6 is also a yes, automatically. All right? So that's pretty cool. I like that one a lot. So if 2 and 3 work, then 6 works. Okay, and now, let's see, that's this one here. And see, what do I have left here? I got 4, and I have 8, and I have 7. All right, so I'm going to do 4 next. That is blue. Blue. So we got 4 next. So 4 is an interesting one. So 4, so you look at the last 2 digits only. Okay, last 2 digits. If they are divisible by 4, then the whole number is yes. Okay, so for 4, I look at the last 2 digits. That'd be 71. I'm looking at just 71 right there. If 4 divides into 71 evenly, then that means it divides this whole number evenly. Clearly it does not, right? 4 does not divide into 71 evenly. Therefore, this number is not divisible by 4. And then we have 8. 8 is very similar to 4. So you don't look at the last 2 numbers, you look at the last 3 digits. And if that's divisible by 8, then yes. Okay? So for 8, I'm looking at 271. Does 8 go into 271? Well, I don't think so. I don't know anything that equals 8 times 27, or 8 goes into 27, so this would be a no. But it's, it's not super easy. It's not as easy as some of the other rules, but it's better than dividing the whole thing out and realizing it doesn't work, right? This really is really great for when you're trying to find common denominators. These rules can help a lot. Okay, so you might notice how I've set this up a little bit. So these are both kind of blue, or they are blue, I should say, right? And that's because they're kind of the same. You look at the last 2 digits. If it's divisible by 4, then yes, the whole thing is. Or you look at the last 3 digits. Divisible by 4, then yes, the whole thing is. So those are kind of go together. Then you might notice that these ones look kind of reddish. And the reason those are reddish is because they go together. They're kind of the same rule. So I have 3 is the sum of the digits, and 9 is the sum of the digits. So it's just a matter of divisible by 9 or divisible by 3. So those are basically the same rule. Then you notice that I have these harsh looking colors right here. Also, right? And those are similar too, because if they end in a 5 or a 0, or they end in a 0. So those are very similar rules. I kind of could put 2 in there as well, because it's also looking at the last one, but I didn't really do that. So then we see I have this purple one here, and the rule for the purple one is if 2 and 3 work. Well, 2 is a blue color, and 3 is a red color, and blue plus red equals purple. So this one and this one go to that one. Right? So I kind of grouped them together, give you some little connections there, like 3 and 9 go together, 5 and 10 go together, 4 and 8 go together, and then 2, 3, and 6 go together. So that's kind of how they're grouped. Now you might be noticing that there's a number that's not included in here, and that's the number 7, right? There's no rule for 7. There's no divisibility rule. So if you happen to come up with a divisibility rule for 7, write it down, send it to me, and then when I write my book, I'll take credit for having figured it out. Kidding, of course. No, yeah, there's no rule for 7. So we don't do anything with 7. That's why it's that weird funky orange color. So just 2, 3, 5, 6, 8, 9, and 10. And again, we'll see how these will help us later when we're trying to find some other values of doing some problems. But the divisibility rules are very good, and we want our students to use them, so we have to give them opportunities to apply these rules as much as possible. Okay, those are the videos for this week, and have a great weekend. I will be posting some homework later today, and have a great weekend.